Hello friends, welcome. Those who are following me on YouTube probably know that recently I have recorded a lot of videos on the operators' ability to monetize their 5G networks. And in the process, I have identified some of the bottlenecks which will prevent them from doing so. One of the critical bottleneck is absence of sufficient capacity in the Wi-Fi network which you use inside your house, which is acting like a bottleneck. Let's understand the reason why it is acting like a bottleneck and what we need to do in order to resolve this problem. We in India know that one of the killer application of 5G is fixed wireless access. And why? Because India's fixed line broadband penetration is very low compared to any advanced economies in the world. Today we have roughly around 30 million fixed line broadband connections, and most of the broadband connections, or maybe let me just put it this way, that a large fraction of the broadband connection is not on optical fiber. That is preventing the Indian consumer to able to use broadband effectively, because mobile broadband cannot be relied upon because it is extremely uncertain and unreliable. So therefore, we are trying to use 5G's fixed wireless access capability to enhance our penetration of broadband connectivity within our homes. And how it is done? We have this 5G BTS, and this 5G BTS is basically able to throw a signal in which is going to be received by an antenna located in the rooftop of your house, and then this antenna is going to basically extend Wi-Fi connectivity inside your house using a router. This router is going to send Wi-Fi signal, which is going to be received by all your devices inside your house. Now, why it is so effective that this whole system works? The reason it works is because inside the house, though the high frequency 5G spectrum does not penetrate, which is 3.5 gigahertz and 26 gigahertz, they can be very easily received outside your house by a pointed beam emanating from this BTS line of sight, because that beam becomes very narrow, and because of the gain of both these antenna on both the sides, the speeds of these network, this link can be extremely high. And if we are able to extend this speed inside your house without any bottleneck using a Wi-Fi network, then these devices which you are seeing here inside the house become quite empowered. Now the problem that we face today is that the Wi-Fi router inside the house doesn't have the capability to extend what you are receiving outside your house using the 5G network. Sometimes the speed can be much more than 1 Gbps. And the reason is that this beam is extremely pointed. As I told you that, there could be multiple beams. There will be extremely pointed beams especially in the 26 gigahertz band, and therefore the limitation of the high frequency spectrum, which is not having a very good propagation characteristics, can be overcome by the high gain of the antenna on both the sides. That is where we are going to basically focus on, because what is the capability of the Wi-Fi network that we have today, which is preventing the full exploitation of this speed which we are going to get. And if you are not able to do that, then our broadband penetration using fixed wireless access terminals will be severely limited. So let's understand how a typical Wi-Fi network works. Now in India, we have got two different bands, 2.4 gigahertz band and 5 gigahertz band. 2.4 gigahertz band has a total of 80 megahertz of spectrum. 5 gigahertz band has a total of 605 megahertz of spectrum. But it is broken into two blocks of 200 megahertz and 405 megahertz, and there is a gap in between of 120 megahertz. Now, Wi-Fi network does not work like a conventional terrestrial 5G network. The reason is that in case of a terrestrial 5G network, the spectrum belongs to the operator and he doesn't have to deal with interferences within his block of spectrum. Whereas in case of Wi-Fi network, this network is not going to be interference free. Means whenever you are trying to transmit your Wi-Fi signal within the house, there could be another router here or maybe in your neighbor which will start causing interference to your router. Therefore, your network is not going to be interference free, and therefore what the Wi-Fi technology has been able to accomplish, that it's able to break this particular block of spectrum, both these bands, into small chunks of one particular carrier size, and that carrier size can be 20 megahertz, 40 megahertz, 80 megahertz and 160 megahertz. So the Wi-Fi network picks one of the chunks at a time, not the full band. That's a misnomer, that let's understand this. It doesn't pick the full band of 605 megahertz. It's not able to use the full spectrum at a time. It is only able to use a individual block of spectrum, either 20 megahertz, 80 megahertz, 40 megahertz or 160 megahertz. And how it decides which particular block to use? The most interference free block is chosen at a particular point of time, depending upon how the Wi-Fi network is able to sense the external environment. If a certain block of spectrum in your environment is interference is infested with interference because it is being worked upon by another Wi-Fi router nearby to your house or within your house, then that particular block of spectrum is not going to be excluded and some other block will be chosen. And it all depends upon that what is the maximum size of the block that the Wi-Fi network will be able to extract optimally out of that interference environment that gets created because of many devices working together. So this is where the bottleneck comes. If you have a certain block of spectrum which is continuously interference prone, then the likelihood of finding a larger block of spectrum 160 megahertz is going to be low, because higher the block size, more will be the speed, right? It's very simple to understand that. So if you are going to find only a 20 megahertz block, then your speeds are going to be low. If you are going to find a block of 160 megahertz, therefore speeds are going to be higher. So that is the reason why this particular constraint is coming. The second constraint is that there are two different bands. One is 2.4 gigahertz band and another is 5 gigahertz band. Now if you already see that the 2.4 gigahertz band has only 80 megahertz of spectrum, which is pretty low. Therefore it is not very useful, but only advantage of 2.4 is that its reach is better inside your house, which I am going to show you in the next slide. Whereas in case of 5 gigahertz, you have got a lot of spectrum, but its reach is quite less compared to 2.4 gigahertz band. So here is what I conclude in this chart, that Wi-Fi uses only one block, the most interference free, from either 20, 40, 80 or 160 megahertz, and Wi-Fi uses only one band at a time. The conventional Wi-Fi network that we have till Wi-Fi 6, either 2.4 or 5 gigahertz. So it will choose between either of the two. If 5 gigahertz is very interference free or it's not able to reach the device, it will choose 2.4. But if your device is conveniently placed in a proper area close to the Wi-Fi router, and this particular band is less infested with interference, then it will choose 5 gigahertz. Now there is one more problem. The problem is that if you choose 160 gigahertz, then the number of channels that you get or number of options of blocks that you get is pretty low, which is 3. Means out of 3, you have to choose 1, right? That is why the probability of choosing a higher block size reduces significantly, because either of the 3, within the 3, if one is more interference, less interference, infested with less interference, then you will be able to choose that. But since your option to choose is limited, therefore the chances of choosing this higher block is pretty low. That's why your Wi-Fi speeds are going to be low, because most likely the Wi-Fi network is going to choose a block of lesser size, because there are more options available. Now coming back to the other point, which is that the speed is also dependent upon at what distance from the router which you are located at the house. Now if you see here, if you are located very close to the router, means let's say if your router is located just near the your device is the computer is located just near the router in a distance of let's say half a meter, then you probably will get very high speed. because your speed will decrease exponentially as you go away from the router. Even at a distance of 8 meters, you see there is a huge amount of power loss which is happening, right? So this minus 58 dBm is for 2.4, minus 65 dBm is basically 5 gigahertz, right? And since the aperture size, the receiver aperture size is basically related with, is directly proportional to the size of the wavelength. So if you are going to be on a lower frequency, your chances of receiving that signal is going to be higher compared to if you are on higher frequency, because your receiver aperture is going to be less. And that is why this distinction is there. 58 dB versus 65 dB is only because of the receive aperture, because propagation characteristics of all radio waves is similar, but the receiver aperture reduces, and that's why there is a huge distinction between 5 gigahertz band and 2.4 gigahertz band. The other problem that you are going to face is penetration of wall, because in the house you are going to have a lot of walls, and as soon as a penetration occurs within a wall, there is always a loss of 3 dB, means your power is going to go down by half. So these problems actually reduces the theoretical capacity of the Wi-Fi router to a very nominal level. Means it is going to be, suppose the theoretical capacity is 6 Gbps or 3 Gbps, then maybe at a distance of 16 meters from the house or 8 meters from the house, you are going to get a fraction of that capacity, and that becomes a bottleneck. Now, what is the impact of this bottleneck? Let's understand this. The impact of the bottleneck is, as I told you, that we have huge amount of spectrum for 5G. Today, operators have taken 26 gigahertz band as high as 1 gigahertz and more. So you have got 1 gigahertz of spectrum, and that too pointed beam, and therefore your ability to, transmit huge amount of data is extremely high. Similarly, in 3.5 gigahertz band also, you will have high capability to transmit data, because most of the band is going to be completely used, and you can do segmentation of the beams in spatial dimensions also. Means you will be able to separate out multiple beams spatially, and therefore this channel, the bottleneck that the channel, theoretical capacity of the channel defined by the channel theorem, is not going to play here, because you are separating the beams in a very narrow beam within the spatial domain. So you have got huge capacity, but inside the house you do not have the capacity because of the problem that I am explaining to you. That is where the issue comes, that 5G monetization will be a difficulty unless the inside the house Wi-Fi capacity is increased. Now, how do you increase Wi-Fi capacity? You find a new band, like for example 6 gigahertz band. 6 gigahertz band has got 1.2 gigahertz of spectrum. Even if you take a fraction of the spectrum out of the band, let's say 500 megahertz spectrum, then also you will be able to enhance your capability to find a larger block size of 160 megahertz, much higher, with much higher probability, because within a 500 megahertz spectrum, you will have at the additional 4 to 5 blocks, right? So you will be able to increase this number significantly higher, and then the probability of interference within your Wi-Fi network is going to be low, because there are 3 bands to choose from. 2.4 you can just simply ignore, because there is not enough capacity. But you have an option to choose between 5 gigahertz and 6 gigahertz, right? So it is important that 6 gigahertz band is delicensed. If you don't delicense 6 gigahertz band, then your ability to monetize 5G technology will be at risk. Even the bands which you have bought, the operators have bought today, which is 26 gigahertz band and the 3.5 gigahertz band, will remain underutilized. That is very important to understand. It will remain underutilized. So therefore, it is important to find new spectrum band for Wi-Fi. Second important point will be that the government is going to lose revenue. Why? Because if suppose you are going to use the 6 gigahertz band for IMT, and you are already facing a problem of underutilization of your existing spectrum, then what you are going to do with the 6 gigahertz band which does not penetrate indoor? Because you will naturally would like to use all your spectrum to push broadband connectivity inside the house, because outside the house 3.5 is already there, and mobiles do not require that kind of capacity. You need capacity to connect broadband connectivity to your computer, to your devices, your TV, or maybe futuristic devices which is going to come, which might require that kind of speeds. But those devices will generally, most of the time, 90% of the time, will operate inside the house, not outside the house. And outside the house, these spectrum bands of the high frequency, inside the house, these spectrum bands of high frequency do not penetrate. So the government will not be able to sell any additional 5G spectrum going forward. So there will be a loss of around 2 lakh crores to the government, because the 6 gigahertz band will not get sold, even if it is identified INT. Then there is another 2 gigahertz of spectrum, more than 2 gigahertz spectrum in the 28 gigahertz band, and plus 26 gigahertz, that is not going to get sold. And then the 3.5 gigahertz spectrum will also not get sold, because there is already a lot of spectrum available in 3.5. And then on top of it, that the 6G aspiration of the government is going to be impacted, because all the 6G spectrum is actually at the higher frequency band. Even the technology will have the capability to do much more than what 5G is capable of doing, but you cannot change the physics of the technology. You cannot basically come out with a new invention to penetrate indoor unless you put your 6G base station inside your house. You still need Wi-Fi technology to basically support in-building connectivity with all the devices, right? So your 6G aspiration of India is going to be also get impacted. And then if you are going to go against the world, because the whole world is going towards delicensing of 6 gigahertz band, and all the major economies either have delicensed the full 6 gigahertz band or a portion of it. Now, if India goes for full, and this includes China, by the way, China is not pushing for the full 6 gigahertz band for IMT. They are basically going for only that particular portion, which is, I'll just show it the slide to you. Look at this, that we have got USA, Saudi Arabia, Korea, Japan, the full 6 gigahertz band they are basically talking about, they have delicensed, whereas Europe has delicensed a portion which is 500, and they're talking about IMT for the rest of the 600 megahertz or 600 megahertz. And then China is also talking about IMT for this particular portion, not this portion. India is talking about, in probably people in the Indian operators are basically talking about that we need the full 6 gigahertz band for IMT, which you don't, and you are going to be going against the world. And if you go against the world, what will happen? Economies of scales are going to get impacted. Manufacturing India is going to get impacted, because you will come out with a foreign equipment which you are not going to use, because there will be no volumes of economies of scale with the rest of the world. And the most importantly, India is going to lose out on opportunity cost, because most of the 5G 6 gigahertz band is currently occupied by lot of existing legacy networks, like the existing microwave links, ISRO, satellites, etc. If you see, this whole 6 gigahertz band is occupied by a lot of existing legacy services. Now, these services can coexist with Wi-Fi, because Wi-Fi is at a lower power, but they will not be able to coexist with IMT. So unless these point-to-point microwave links are being used by the operators for their existing 4G and 5G network, so unless they dismantle this and connect all their base stations with Wi-Fi networks, which will take another 7, 8, 10 years, God knows how much time it will take, and the ISRO does not dismantle all their satellite, how will you use most of the spectrum? Tell me. So, but you can use Wi-Fi, because Wi-Fi is indoor. It's not going to get impacted. The power levels are pretty low. So that is the opportunity cost that India is going to lose out, and that's where India needs to immediately delicense at least a portion of the 6 gigahertz band to unlock the capability to monetize this 5G network and future aspirations of 6G network. I think you probably understood why it is important to remove the Wi-Fi bottleneck, and I will like to stop here, otherwise the video is going to become very long. And if you have any comments, you can actually put in the comment section. And thank you again for your time, patience listening. Thank you very much.